Hi. Hello, everyone. Welcome to my presentation here. My name is Balaji Ethirajulu. I work in Ericsson in Business Unit Cloud and IP. So here today we're predominantly going to talk about service assurance and the network analytics and how it will impact the future networks, right? So first few slides, couple of slides, I'm going to talk about what's happening in the telecom industry as well as the pace of change that's taking place in the industry. The second part of the presentation, next couple of slides, I will talk about how it will affect those changes and the trends, how it will affect the telecom network itself, and then also as part of that, how it will affect the service assurance and the analytics solution. And the third, I'll talk about a solution that can address some of these needs. This is the pace of change I was talking about. As you see in the screen, it took about 100 years to connect a billion people, basically the fixed telephony. And what we have done in the next 25 years after that, we connected 5 billion people. That's actually mobile phone. So you can see 1/4 of the time, we did about 5 times more connectivity, connecting people. We also forecast by 2020, there will be 26 billion connected devices, basically things to things, things to humans. And also we go back to our Ericsson with our original vision that we stated quite some time back, that we stay by that, which means we'll have about 50 billion connected devices as well. So we're going to reach all the way to the 50 billion. The question is, now you can see the pace of change and the number of devices, not only the phones, but M2M, all of it, IoT, Internet of Things, and how that's going to affect the network. So we'll see in the next few slides. So what we see in the past, even today, people consume over-the-top services that goes over the traditional telecom networks. And some of the people, enterprise or customers, retail, they would like to pay some amount for a premium experience. So that is also goes through this network, right? That's what it is. And but tomorrow, you cannot just create networks one for vertical industry, one for healthcare, or one for shipping industry. But it's all going to be one network, but will deliver multiple industries. So what will happen is, because of that, there will be a tremendous requirements compared to what we have today, especially from the M2M on the latency. So some of you drive car or certain, if you have M2M device, you cannot wait for the reaction, several milliseconds later. It has to be pretty quick. So just an example. So the latency of the network, there is a demand on the network on the latency. Absolutely, there is another biggest thing is security. The way I'm talking about all of this is that is where all of us are working in a different layer. Some work on the cloud infrastructure, some in OpenStack, some in OpenDaylight, and all of that eventually to deliver the end user services and different industries. That's what it's all about. We're going to meet those demands. So the M2M will drive the security, high security, because some of the devices are very old legacy devices. There is no security built in. And take those devices, it could be a key place, it could be in a power sector, it could be in a nuclear power plant, whatever. Those devices are sending traffic, they're unsecure today, but when you put them in an IP network, it requires a lot of security. Otherwise, we won't get that business. The security is a key thing. So, how you can accommodate all of this? That's where we are all here at this OpenStack. So we are creating a network that's very agile and programmable and expose service to the upper layer. So we can actually do different applications, not only the traditional telecom application to different applications. So making our network very agile, right? That's one of the things. So as you see on the slide at the other side, what we're talking about, this is part of the 5G story. So 5G is not just the mobile going 3G, 4G to 5G. It's all about end-to-end service. So we start from the cloud, the applications are in the cloud. You deliver that through the transport. All of them should be agile. And then from the transport, you deliver to different access. For example, radio access, to meet the demands of the multiple vertical industry. So for example, shipping industry. If you take a shipping industry, we can actually deliver the whole mobile core for a ship. So we have use cases that we deliver for a wine industry. So in Germany, they want to make better wine than the French, and then they wanted actually telecom people are helping put together a solution for them that they can predict the devices and everything. So all of this traffic will go through this. And many of them virtualized and they're available in the data center. Now we saw the two slides where I showed the overall, what's happening in the industry, what all is going to happen as well. But that's going to impact the network now. So what are all those impacts? For example, if you see the networks will constantly change, so the managing system that is managing the network, whether it's service assurance or analytics, you can just cope up with those changes and actually support with the new tools, right? In the past, the telecom network, the network function, what we call, probably many of you probably aware of that. When you make a call, it goes to a mobile network, mobile core, where there is a network function called EPC. MME, EPC and MME is EPC. Then you have the IP intermediate subsystem IMS and MTAP. All these products, network function, deliver those services. Now all of them now from a traditional infrastructure, they're going to the vertical infrastructure, right? That means the physical layer is gone. The service assurance is to manage those together. So we're able to actually correlate and actually take action. Now since it's gone to the the cloud, that means we need to take data from the OpenStack. Basically, we take data from ceilometer. I'll explain to you, show a quick snapshot of a demo actually. So we take and we correlate that information with what we call hybrid networks, meaning for a foreseeable future, the networks will be hybrid. Everything cannot be OpenStack overnight. The TDM IP took 10, 15 years since 90s. It's still there. Some of them are TDM. We foresee many things will be hybrid physical in nature. So the management system has to cope up with the whole hybrid because the services will flow from the cloud to the physical, back to the cloud again before entering to the, before consumed by the subscriber. So it's very important to have that hybrid scenario. That could be 10 years, it could be the same scenario. So we need to have the whole thing. So in the past, the service assurance are very legacy oriented. We're waiting for the system to fail and then we take action. That cannot be taken. You cannot do that anymore because one of the cornerstones of NFV and SDN is agility and automation. Without that, I know there's a lot of automation is going on in OpenStack, OpenDaylight, at the infrastructure layer we can do. But if there's no automation on the application layer, there's no automation, you're not realizing the full automation. So analytics will play a key role to do the predictive, what we call predictive analytics, that we can take action on the network before even the event occurs. And why it is so important, I'll show you that. So the result will be a well-optimized telecom network to deliver services for different use cases, deliver services for different users, and different services, right? Here is a solution that I was talking about. I'm sorry, the letters are changed a little bit, but that's okay, as long as you can read. Yeah, so what I call here, the product name is Ericsson Network Manager. So what it does is, it has got several other functions. In mono architecture, it's a VNF, Virtual Network Function Manager. And also it has network slicing orchestration capabilities. But here I'm specifically, for this subject, for this presentation, I'm specifically going to talk about analytics application, how that is going to help, how that will play a catalyst role to create that automation and agility, right? So what we do is we're taking, as you see, we're taking data from different sources, the legacy, and also we take data from many OpenDaylight, also our SDN application. And for this event specifically, you could say we take data from ceilometer stack, right? Most important here is NFV application aware scale. That's what is very important. I'll show you why it is. You can scale. You can throw a couple of CPUs in the data center because my load is going up. That's not going to work. Looking at the application, it may not even help the application. So we need to see the application layer and then take action and then spin up the CPU. I'll talk about it. Okay. We go to the next slide. So this is what I was talking. So we take the data from the PNF and also from the virtual network function. Also we take data from the NFVI, then on the ceilometer project from the OpenStack. All this data is taken and then it is actually our machine learning algorithm. Before that actually, there's a process called extract, transform, and load, ETL process, where we take all the data and then pass them. And then it's actually, we correlate them. and then we analyze the data, also use it for some other purposes, for performance management. Then this data is processed and sent to the machine learning algorithm, which actually gives us the insights and conclusions based on the algorithm. And then we can use those insights and conclusions to automate the process, to create automated responses. Many of our operators, they say, okay, you have I'll show this slide, next slide. They talk about automation, but sometimes they say, well, we don't want to automate completely. Okay. So let me go to this. So this is the interesting piece. So that's what we're talking about. So we get this automate all the information, and machine learning algorithm predicts the cloud load prediction, and then we use the policy decision, policy engine, and then use an orchestrator to take an action to actually close the loop, actually to spin up a CPU resources in the data center. So now, in the interest of time, I'll go right to the this one. So you see, this is our product, where you see the dashboard, and you can see the specific KPI there on the top, right? What it says is that specific traffic affecting KPI will drive the maximum utilization in a data center with the CPU utilization in the data center. Now we can predict at what time, even a day before or a week before, based on the predictive analytics capability, 10 minutes before the event, it can actually predict at a, say, 95% confidence level, and we can take action and spin up a CPU ahead of time. So there's a difference now between those two models. The first model, what you see, without the trigger apply, meaning there is no prediction, nothing, someone in the data center, infrastructure layer, they just see, okay, I got 9 CPU, they're running hot, I'm going to throw in a couple of them. But telecom load is a very, very funny load. It's not like a regular load. See what happens on the top picture, there's 2 CPUs added right here, right, the green ones, after the brown curve. The brown curve is the KPI, actual traffic load. But you see the CPU 9 and 10, they're not coming down. They're still hot. Whereas we instantiated, based on the application of our scaling, new CPU in the bottom graph before the event occurs, and the CPU load comes down pretty quick. That's what the telecom network is very, very funny way the behavior is. So it's important not just to have end-to-end analytics, application of our end-to-end network. That's the key part that I want to explain. Okay, due to time, I run fast here. So these are the key takeaways. So automation and network agility are the cornerstone of NFV and SDN, which is very critical. We see the service assurance will play a major role. In the past, when operators make a decision, they build the network, and then this is the investment when they build the network, they buy the fulfillment system to deliver the services, and of course, service assurance gets some money. But now it's just opposite. They're spending, okay, I build my network, data center, everything, but they're trying to invest more on the service orchestration, the automation. Those are the key areas the investment will go. That's very critical to reach that goal of service agility, network agility, and automation. The last, but not the least one here, so this product will be integrated about under 1,000 system we already have, our legacy system called OSS RC system. So eventually it will be migrated into this system. So we have a footprint of 1,000, and we are a leader in this area because of that. Thank you very much.